Hi everyone, it's Mrs. Woodruff back for day 2 of cones. We'll do a quick little review of the cone formula, and then we're going to do a couple of problems that are called composites. That means they have more than one shape put together. So let's start off with this first problem where April is filling 6 identical cones. You're going to notice I circled the 6 and underlined the cones. I don't want to forget that we're actually going to have 6 at the end, not just one cone. And I'm also underlining cones because as we go forward, we've always got to keep our eye on what shape are we working with, because we now have cylinders and cones. Each cone has a radius in this problem of 1.5 inches. I've underlined that. And the height is going to be 9 inches. So notice by kind of just doing that little bit of underlining, I have all the information I need to move forward. What is the total volume of the cones? That's all 6. And we're going to round to the nearest tenth. We're going to remember that our volume formula is really found from taking our cylinder formula and dividing it by 3. So our cylinder formula was pi r squared, that's the area of the circle of the base, times the height of the cylinder. And then if we divide it by 3, we get the volume of a cone. So in this particular case, the radius of 1.5 is going to substitute in for r, 1.5 squared. The 9 is going to take the h spot, and we're going to calculate the volume of one of the cones. So there's my radius, there's my height, and there's my substitution. The 1.5 squared gives me 2.25. I multiply it by 9 and divide by 3, and you should see 6.75 pi. This is called the exact answer. We haven't approximated and we haven't multiplied by pi yet. So that would be precise. And the minute we pick up our calculator and take 6.75 times the pi button, you're going to see 21.2 inches cubed for one cone. Now I need to remember what I circled up here is that she's actually filling 6. So we need to take that volume for 1, multiply it by the 6 cones, and when we take 21.2 times 6, we'll have 127.2 inches cubed. Now let's put some shapes together. It's called a composite. So if you look at this shape here, sometimes it's hard to see. So let me use the screen so you can see that on top of this kind of odd shape is a cylinder. The cylinder has a diameter all the way across the circle base of 8 feet. And the height of the cylinder is 4 feet. To find the volume of just that piece of this shape, I need to take pi times the radius squared. So I'm not going to put 8 in for r. I'm going to cut it in half. My radius is 4, and you'll see pi times r squared, 4 squared, and this other 4 is the height. So pi r squared times 4 will give me the volume of the cylinder. 4 squared is 16, and 16 times 4 would be 64 pi, and that would be the exact answer for the cylinder. You'll see it right over here. And if I take 64 times pi, it's about 201.1. Now I need to caution you that our book often uses 3.14 as an approximation for pi. So if you use the pi button, you might be slightly off, but the pi button is actually the more accurate way to go. Now that's the cylinder. Now if I look at the bottom, let me just put the screen up there. Can you see that cone that's on the bottom? Okay, so now we're going to find the volume of that cone. The cone has the same diameter that the cylinder did. So again, we're going to be using a radius of 4. But this time the height of the cone is a little bit bigger. It's 5 feet. So we're going to take pi r squared times 5, but we're not going to stop there because it is a cone. We have to divide it by 3, and again, the book likes to show multiplying by 1/3. When you multiply by 1/3 or divide by 3, that's the same operation. So I square the 4, 16, I multiply by 5, and divide it by 3, and that would be 26.6 repeating in the calculator. And 26.6 repeating pi would be your exact answer for the volume of the cone on the bottom. I could add those two together and get a combined exact volume of 90.6 repeating pi, or down here, just like we did up above, I can take that 26.6 repeating, multiply it by pi, and notice it's about 83.8. Now if I add the 201.1 cubic feet from the cylinder with the 83.8 cubic feet from the cone, this odd kind of looking shape over here could hold 284.9 cubic feet. That would be the volume. Okay, let's just do one more. And if you look at this shape, I hope you can see there are two cones in there. One is pointing to the left and one is pointing to the right. I have added these little dotted lines to show you some of the things going on. So if you look at the, I'm going to just trace that left cone there, okay? He's actually laying down. He's fallen over on his back. His height is actually this blue dotted, which is the 5.5. And this red dotted is representing the radius of the base circle. Now the right-hand cone is also laying down. He's quite a bit taller at 13 inches, and he has the same radius on his base circle of 6 inches. What we need to do is calculate those two volumes, the left and the right, and then add them together. So I'm going to give you a second to do that, so please pause the video and give it a try. Okay guys, let's see how you did. Remember, this is our volume formula. We're going to take pi times the radius squared times the height of the left-hand cone, divide it by 3. And we're going to do the same thing with the right-hand cone. And when we're done, we're going to add them together because these two cones are stuck together. So we're going to add their volume. So the left-hand cone has a radius of 6 and a height of 5.5. So I'm going to square the 6, multiply it by 5.5, divide by 3, and that would give me 66 pi. 66 pi inches cubed. That's your exact answer. Now 66 times pi would be about 207.3. Our units are going to come in a second. I have not forgotten them. Now we're going to do the right-hand cone. His radius is still that 6 inches, but the height is longer at 13 inches. Here is my substitution into the formula for volume. The 6 was the radius, so r squared. The h is 13, and we're going to divide by 3, and you're going to see an exact answer of 156 pi. I'm going to multiply pi and get an approximate answer of 490.1 inches cubed, and I'm going to add these two together. Now, if I add the two exact answers together, I would get an exact answer of 222 pi. And if I needed to do an approximate and I add the 207 and the 490 with their decimals, it works out to be about 697.4 inches cubed. So composites really aren't that tough. It's really just kind of like doing two problems in one and either adding or subtracting at the end. Both of the problems we did today are adding, but if you have a hole in the shape like we did with the cylinders, then it would be subtracting. So I hope this helps get you started on some composite volume problems. Again, I've copied the pages from the book and they'll be attached to Classroom. So give it your all, guys, and have a great day.